Hello folks, fellow YouTubers and friends. It's been over a year since I've done anything on my solar powered gasoline wheel. I've ordered some special parts for the two-stage oscillator and it's going to take a while for them to get here, so I figured I'd put a little more work into this one. I've come up with a better idea, I think. We're going to try it. This is the first time I've ever done this experiment, so if there are any surprises, you're going to see them right along with me. I was thinking water is twice as heavy as gasoline. So if we could push water from one side of the wheel to the other, then we'd have more torque for the same size machine. The gasoline gets warm, it builds up pressure, blah blah blah, but it won't mix with water. Alcohol will mix with water. This is a half-gallon vodka bottle. It's approximately 8 inches here. There are 2 inches of good alcohol in here. It's about 91 to 93% pure alcohol, grain alcohol. I'm going to fill it up with room temperature water. I have a pot here of super hot water and a pot here of cold water. I have here a lid with a tube going through it, which is sealed, and the tube goes all the way down in the water, and the other end of the tube will go up into this bottle. I'm hoping the heat from the water will cause the alcohol in the water to build a pressure and push down on the water and push it up into here. Then take it out and put it in the cold water, shrinking the gas and causing it to suck the water back. It'll take a few minutes, so during that time I'll explain a little bit more about what the heck I'm up to. Okay, here we go with there's the alcohol. This is the water. I'm hoping the water mixes thoroughly with the alcohol as I pour it in. That's why I put the alcohol in first. So hopefully it will cause a mixture. Now to prove to you that it is water, straight out of the tap. Yuck, and room temperature. Alright, in goes our tube. Now we're going to set it down because I don't want to break the glue around the seal, so I'm going to turn the bottle to tighten it down. Hopefully there's no surprises. We're going to take this tube and stick it in here, and then we're going to take this and set it in the hot water and see what happens. If anything. Oh well, nothing. There it goes. There it goes, right there. Can you see it? Right there. It's going to work. Coming up pretty daggone fast, but again, this water is really hot. A lot hotter than the sun would be on it. And I think this tube is just a little bit long.
Hi, Dad.
Hey, kid.
What are you talking to?
Camera.
Oh. Where is the camera anyways?
Over there.
Where? Oh.
Okay, the water height is right here, right now. So the alcohol in the water will work. It'll work fine. Keeps the cost or the expense down on building the gasoline wheel, which this tells me we're going to have to change the name. On one of my last 2 videos concerning the solar powered gasoline wheel, one guy made a comment about it being a similar to a Minto wheel. I don't want to take credit for anything that somebody else has done. This is where I got the idea to do this. And, oh, that's my son, Jonathan. Waves the camera, son. Anyway, Wallace Minto built the Minto wheel in 1947, roughly 6 feet in diameter, and it worked fine. It worked great. In 1953, Mother Earth News magazine built one 23 feet in diameter, produced almost 5 horsepower. They were filled with propane gas. That's a lot of pressure. And Mother Earth News made 2 major mistakes in their wheel. Number one, their crossover pipe was entirely too small and their tanks too large. You couldn't get enough heat in fast enough to do any good. And it took forever to get the heat out. That's the thing about a heat engine. It's not so much how much heat you can put in it, it's can you get the heat out as fast as you put it in. Where are we right now? Okay, we're right here right now. We're doing real good. I'm hoping that the water's, oh Lord, the water's not going to be hot enough long enough. It's still warm. But, well, let's see. Maybe we'll put a heat gun on it. That might help a little bit.
Can we see videos on your computer? Can I see videos on YouTube?
Yeah. But anyway, there's been hundreds and hundreds of people experimenting and playing with the Minto wheel since Mother Earth News did that in 1953. And I don't want to slight anybody, and I'm not throwing dispersions at anyone, but it seems to me that someone once said a perfect example of insanity is to do the exact same thing, the exact same way, over and over again, and each time expecting a different outcome. Mythbusters, a few years back, tried to produce or reproduce a Minto wheel using 20-pound propane tanks. I think they had 6 of them. They built it exactly the same way. Big old tanks, really small crossover pipes, and it worked, but Mythbusters being who they are, they're more out for ratings than they are science. I'm going to build a Minto wheel, and I guess what we ought to call it is modifications to the Minto wheel, because I've got a totally different design. There'll be no crossover pipes, and we're not going to use propane because we don't want to get into something here right now. We don't want to get into what was I going to say? I lose my train of thought every time. Anyway, we've got some modifications to the Minto wheel. There's not going to be tanks, it's going to be pipes with heat sinks on them, so it'll suck in more heat faster and give off more heat faster. There'll be quite a few of them, rather than 6 or 8 big old bulky tanks. It's almost impossible to get heat into. We're going to use just pipes, rows and rows and rows and rows of pipes, and we're going to have heat sinks on the pipe, I hope. But we'll see. But this is definitely going to work. Definitely. Taking a little bit longer than I thought, but what the hell, if you're going to use sun power, it shines all day long. The thing about the Minto wheel is it will run at night just as well as in the day. Well, not just as well, but it will run at night. All you got to do is get one side warmer than the other side, or one side cooler than the other side. And about 3 to 4 degrees temperature will do it. It will run really slow. It's not the temperature that, per se, it's the amount of heat. Water turns to steam once you get it to its boiling point, which depends entirely on the pressure on it. At sea level, it boils at 212 degrees. On top of Mount Everest, it boils at a whole lot less of temperature. However, the amount of BTUs it takes to turn it into steam at the same temperature, it remains the same. It takes roughly 840 BTUs of heat to turn 1 pound of water into steam without raising the actual temperature of the steam or the water. Water also boils at 55 degrees at 5 bars. Sea level is 1,000 bars of pressure. The atmosphere on Mars is 5 bars. So consequently, water boils at 55 degrees on Mars. I have vacuum pumps that will pump down to 3 millibars. I mean 3 bars.
The internet doesn't work.
Huh?
The internet doesn't work.
Something trying to make it here. Okay. I want to cut this video short. It's not going to do it as fast as I thought. I don't have enough heat. But it is going to do it. We've already raised it up. It's up to here right now. So I'm going to put it in cold water and see how it does without sucking it back down. Okay? Alright, here we go. Well, the experiment didn't run the way I was hoping, but it did work. I mean, we're talking, we're talking 16, 18 inches of climb there in just a matter of a few minutes. And again, we had a big jug, didn't have any heat sinks on it. So let's see how fast it comes down. Holy cow, where'd it go? I can't even find it. Huh. Well, I'll be damned. Oh, it's still climbing. It's all the way up to here. It's taking a while to get the heat off of it. But it's all the way to right here right now. So, oh, there it goes. It's starting to come back. It's starting to come back now. It climbed exactly 18 inches. So now as it cools, it's starting to suck it back, which is exactly what I want. So I think it's going to work. I'm going to do another experiment, but I'm going to use a different chemical other than alcohol. Alcohol has a latent heat. That's the amount of heat it takes to turn a liquid to a vapor without changing the temperature of about 360 or 80, I believe, and I'm not sure. So somebody please double check. But acetone. Acetone is a natural liquid that will mix with water like alcohol. But acetone has a latent heat of 230, taking a whole lot less heat to turn it to a vapor and create a pressure. So if we mix acetone with water, of course I can't do it with plastic because acetone is designed to eat up water. I mean, to eat up plastic. The wheel will have to be made of some kind of metal or a special type of plastic. So anyway, we're going to do a few more experiments with acetone and alcohol and heat sinks and that kind of thing till we get the right liquid to use. Okay? Well, at least you know where I am on the wheel, and I appreciate your watching. Thank you much. And all the credit goes to Wallace Minto. Anything I do will be his wheel, but with my modifications. Okay? Thank you very much. Y'all have a great weekend.